All right, lesson 5, matrix operations. So when you're adding and subtracting matrices, you only can do it if they have the same dimensions. So if you look at these first two, for example, this is a 2 by 3 and this is a 2 by 3. You can do it. So if this was add or subtract, doesn't matter, you could do the operation. All right? And what you do is you just add or subtract the corresponding entries. So this 2 and the 1. This 5 and the 8. This 1 and the 9, and so forth. All right? And then, if it was subtraction, you would just subtract the number. So 2 plus 1 is 3. 5 plus 8 is 13. And 1 plus 9 is 10. And then 3 plus 6 is 9. 0 plus 2 stays 2. And 4 plus 3 is 7. Whoops, I almost made big old parentheses. There's my matrix. Now let's pretend it was subtract instead of an addition problem. That's fine. 2 minus 1 is 1. 5 minus 8 is negative 3. And 1 minus 9 is negative 8. 3 minus 6 is negative 3. 0 minus 2 is negative 2. And 4 minus 3 is 1. Okay, so therefore, that would be the answer if it was subtraction instead of addition. But since they're both 2 by 3s, we're good to go. Now, scalar multiplication. Multiply each number in the matrix by the scalar number outside the matrix. Basically, all you're doing is kind of like what you've done before. We're distributing for the most part. I mean, that's basically what we're doing. 6 times 2, 6 times 5, 6 times 1, and so forth. So 6 times 2 is 12. 30 and 6, 6 times 3, 6 times 0, and 6 times 4. And that's all we're doing, is just simply distributing the 6, multiplying by the 6. All right? Equivalent matrices. Matrices that have the same dimensions, okay, just like before with adding and subtracting, and each corresponding element is the same. So if you're trying to solve for letters, you just set up equations. X equals 5. We're done. You can see 6 equals negative 6. That's obvious. 2y equals 14. So 2y equals 14. Divide by 2. Y is 7. And then z, no work, equals 9. So there are the values of our 3 variables right there. By basic, either just equivalency statements or simple solving. All right, matrix equations. Solve the matrix equation below by finding x, y, z, and w. Okay, this builds right off of the equivalency we just talked about. All right, where this corresponds here and so forth. So if you think about it, this corresponds with this, and that corresponds with that. The 3y and the 6 and the 4. So we're going to get a statement. All right, but the first thing we need to do is distribute the 4. So we're going to get 4x. We're going to get 4 times 3 is 12y. 4 times 1/2 is 2z. And 4 times 9 is 36. This is our new matrix for the first one. And now we're just going to make a statement. 4x plus 5, because the x goes with the 5, right? So 4x plus 5 equals 49. And now we just solve. We'll get back to the matrix in a minute. So we're going to subtract 5. So that's 4x equals 44. Divide by 4. X is 11. So we found our first variable. All right. 12y. Remember the 3y goes with the 6 and the 42. So 12y plus 6 equals 42. Subtract the 6. 12y equals 36. Divide by 12. Y is 3. The z goes with the 7 and the 25. I'm going to go below here. So I have 2z plus the 7 equals 25. Subtract 7. 2z equals 18. Divide by 2. Z is 9. And there was a mistake here. Sorry. This Z should be a W. Otherwise, it'd be confusing because Z is going to get two different answers. So 9 plus W equals 21. Sorry, 36 plus W. My bad. I forgot we changed this. 36. So it's 36 plus W. Sorry about that. Wasn't paying attention to my own work. Now when I subtract 36, W equals negative 15. All right, matrix multiplication. These can be done in the graphing calculator. You can only multiply matrices if the number of columns on the first, the left matrix, is the same as the number of rows on the second matrix. Otherwise, we say it's not possible. So the first thing we want to start off with is just saying 2 by 2 and 2 by 2. And what we're going to do is look at the inside numbers. And since the inside numbers are the same, we're good to go. All right, we need our handy dandy calculator now. Now we're going to go one step further than what we've been doing. We're going to actually set up two matrices. So get our calculator to work normally. Here we go. So we're going to go into matrix like we've been doing. We're going to go over to edit. We're going to say 2 by 2. And then we're going to put in 1, 2, 3, 4. Double check the numbers. We're going to quit. Come back into matrix. Now this time we're going to go down over to edit. Whoops. But we're going to go down to B, and we're going to put a different one in B. And we're going to say 2 by 2. And we're going to say 5, 6, 7, 8. And we're going to quit. And now we're just going to say, now remember, we're doing this one times this one. And order matters, and I'll show you why. So we go to second matrix, and we just choose A. See how it's highlighted number 1? We just hit enter. We can hit number 1 or enter, doesn't matter. And then we're just going to simply say times, go back into matrix, and say B, or we hit number 2. Enter. And there's our answer. Now here's why it matters. Second matrix, if I chose B first, times second matrix A, notice I get a different answer. Okay? So my answer here is 19, 22, 43, and 50. All right. If the answer is the same if you switch order, that'd be, whoops, no. In matrix multiplication, A times B is not the same as B times A. And that's weird because we're used to saying 2 times 3 is the same as 3 times 2. But we're not dealing with just numbers here, we're dealing with matrices. All right, so number 2, we look at this and it's a 2 by 3. And this one's a 2 by 3. Okay, cool. But when we look at the inside, these numbers are not the same. Okay? It's called dimension mismatch. And if you put, I'm not going to do it. I'm not going to spend the time on it. But if you put this in the calculator, A and B, and you tried to multiply them, you would get this error message. That's not possible. But I'm not going to spend time going through the calculator just to show you it doesn't work. All right? That's what would happen. All right, let's look at this one. This one is a 1 by 4. And this one is a 4 by 3. We look at the inside numbers. They're both 4. We're good to go. So we go into our calculator again. We go to matrix. We go to edit, the first one. And we're going to change it to 1 by 4. And we're going to put in 8147. So 8, 1, 4, 7. And we're going to quit, go into matrix, and we're going to go to edit, come down to B, and we're going to change this to a 4 by 3. And put in, now just be careful here, 6, 3, 95. and 2, 8, 17. Just double check your numbers as you're entering them. 4, 2, 35. And 8, 1, 4. Double check real quick. 8, 1, 4, 4, 2, 35, 2, 8, 17, and 6, 3, 95. Okay. So we have we have them both. Okay. And we're going to type in matrix. We're going to choose A because we're doing A times B times, choose matrix again, go down to B or hit number 2, hit enter, and there you have it, 122, 47, 945. 122, 47, 945. That's our answer. Now, here's the trick. Also, this ended up being a 1 by 3. Your answer is going to be that. So, this says without multiplying, what will the dimensions be? Well, this is a 1 by 3, and this is a 3 by 1. It can be done. The dimensions of the answer will be a 1 by 1. Last one here. This one is 3 by 1, 3 rows, 1 column. This one is a 1 by 3. It can be done, and the answer to the dimensions will be 3 by 3 for the answer. That's what my words were trying to say. Okay, and that's it.